All right, so welcome to IA 215 Automated Work Cells. Today, we're going to talk about an aspect of how you define and get the requirements for your work cells. We're going to be using a lean manufacturing and lean thinking approach, similar to the one that comes out of the classic book from Womack and Jones. They developed a tool set of lean tools. We'll be using one of those lean tools, and that is value stream mapping. We're not going to use it for a complete value stream. We're going to be focusing on one work cell because this is automated work cells, but we are going to be using that approach. And we're going to be using the approach that's provided to us for free from our lean robotics textbook, which is provided to us for free. And so let's begin. Let's start talking about this. Oops. Well, here's an example of value stream, but that's not what I meant to share. This is what I meant to share. All right, so let me try one more time. This is what I meant to share. That's better. So the basic requirement set of what you're going to do, how are you going to build that work cell? Defining that requirement set is probably the single most important first step. And that requirement set also includes other side things like developing a group of people, sponsors, who are going to help you get to that final work cell. So the requirement set is very important. So we're going to use the lean manufacturing, the lean thinking to help us define that requirement set. So we're going to first go through the standard lean methodology for defining what they call a value stream. A value stream is simply a series of steps required to make a product as defined by the value you're adding to that product with a few different other features layered on. So let's go through what we mean when we say value stream. So we're going to first talk about the general approach. And by the way, most of my notes from this PowerPoint came out of the website, which is referenced in D2L. That's an excellent website. I think they had a good lean approach for doing some of the lean work for the value stream mapping. So I'm kind of borrowing a lot of their concepts. So the first step is to basically come up with an approach that makes sense. Talk to leadership, observe, and then document, etc. Talk to leadership means you make sure you have the right sponsors. So leadership might be the your plant manager, it might be the operations manager, it might just be the supervisor in charge of that area. So you make sure you've got the right leadership involved and they are supportive of your work. The second step is to observe. And sometimes you can observe just by being a maintenance operator in the area where the work is occurring. And the key is make sure you're accurate, you collect the data, take good notes. And when I say collect data, count how many parts are a problem, how many total parts per minute. If you see a problem with certain kinds of errors occurring or wasted time occurring, document the conditions when that wasted time or those errors occur. And so we can record the current state, that's the next step, as the value stream map. And then as we record that current state, we start to fill in the future state. So in this presentation, we're going to go through the classic value stream mapping process, and then we're going to talk about the robotics lean approach, which uses a manual task map, which is using a human, and then the robotic or automated task map, which uses either a robot or a combination of automated PLC equipment. So here's some hints. Talk to leadership. Make sure you understand their goals. Let me fix this as I go here. All right. Observe and collect. I don't have to read this to you. Some engineers start with the end of the process and work their way to the beginning. Typical data would include the number of workers per shift, how many shifts, number of total working hours, batch sizes, machinery uptime. Machinery uptime is very important. A lot of times you'll have machines that are down. Sometimes they're down because we don't have enough operators to keep them up. Sometimes they're down because we have failures. Sometimes they're down for unknown reasons. And then you record all that state. Here's a reference. Record the current state first and then move on to the future state. And I like to do almost both at the same time. Usually you look at an area that needs improvement. And the reason why you realize you could improvement is because you're thinking about what that improvement could be. So a lot of times you don't want to just do a generic current state. You're not going to say, all right, this is how things operate now. What you want to do is document the current state and then say, well, if we put a robot here, then we won't have those 4 guys constantly hurting their backs. So this is pretty much the process flow for a generic value stream map. This is how they do it in the lean thinking book. You determine the scope of your value stream map. And then when we get to our work cell, we'll learn that the scope is defining who the customer is and what the inputs are. So you're going to determine the scope of your map. Make sure you map each step of the process. Then you're going to add inventory and wait lines. The inventory tells you, are the parts going to some sort of storage location? Are they coming back to the work cell? What are the wait times involved? What are the times for processing involved? And you'll add that information. Next step is information flow. Information flow is all the documentation that follows an order. And it could be on paper, like a packet. It could be documentation that comes in electronically to the machines that are running that order and then leaves electronically from those machines. So it's important to document that information flow. If you're replacing a manual process with an automated process of any sort, you better darn well know what information that operator has been supplying people, because you're going to have to replace it. And then last, you create the timeline. So the first step is determine the scope. This is the beginning and end point of the process. And typically, we've got a supplier on one end and a customer on the other. Now, most people don't just have one supplier. Most manufacturing facilities have many suppliers. And sometimes we have more than one customer too. So this is the generic value stream approach. When we start narrowing down on a task map for a work cell, we won't have a gazillion customers and we won't have a gazillion suppliers. We'll have much less. So, but this is how we start with a generic work stream. Okay, so we're going to determine the scope of the value stream map. And there's some steps in here. I'm going to skip through them and edit them, I think, because then what we want to add is all the different main processing steps. So the main processing steps come next. And this is where you'd add in this case, they're making a tuna sandwich. So toasting of bread, applying the tuna, packaging, and shipping. So those are the main steps in a value stream process. This is looking at the whole plant, the whole value stream for the plant. We're going to be focusing on the value stream at a work cell, but we'll still do the same thing. We still have to look at the time per step, right? So the total time for toasting the bread is 90 seconds. The total time for applying the tuna is 25 seconds. Packaging, 15 seconds. And then shipping is undefined. All right, one person at each location. So we've got these little codes in here that define one person per location. Okay, so we've added the process boxes, and it looks like I had an editing error there. So CT is the cycle time, the time to complete one part. CO is changeover. So if you have a changeover from one style of product to another style of product, you have to include that changeover time. We haven't really talked about that so far, but most automated work cells are going to have to do more than one kind of product. So the ideal automated work cell should be flexible across the whole range of products for a given product line. And so you might have some changeover to move from one style product to the other. Ideally, if you can, you set up your fixtures and your grippers so that you don't have any changeover requirements. You can instantly move from one product type to another. But practically speaking, that's not always true depending on the business. So the next area is adding inventory and wait times between these process steps. You want to show where those inventories are being created. Are you storing things in a rack? Are you putting them into an inventory room? Are you queuing them up on a conveyor? You've got to define where you're storing your inventory, even if it's short term, and what you're doing with it. Because if you have product sitting in inventory doing nothing, that product is wasting you money. That is considered waste in the lean thinking world, as we've already discussed. So we want to define all that inventory and wait time. So we add little triangles for the inventory, and we add, and we add little arrows with durations, if needed, for wait times. All right, so the little triangles with the arrows show the processes and inventory, and we're going to add wait times. The next step is the information flow, because in any manufacturing process, you got data coming in and coming out, and you need to define where that data is coming from and what that data is. And so what they say in this, from this presentation, you want to show it flowing in. And this can be any kind of data. It can be paper, electronic communication, even an email, even a phone number. Sometimes operators are required to write down on a piece of paper all of their quality measurements as they do a particular manufacturing process, which can be a ridiculous thing to ask an operator to do, or it may be required because you're running a pharmaceutical process and you need that operator to write it and sign it each time. So we add that information flow. And here's an example of doing that. Here we've got, in this case, the information flow is a weekly forecast going to our suppliers. They know approximately how much they'll have to produce per week. We have a daily schedule then that's created that goes down to each one of your work cells, your toasting of bread work cell, your application of tuna wood set work cell, packaging and shipping. And so that daily schedule goes down there. This is an extremely simplistic data flow, because normally I'd expect more than just a daily schedule. I would expect individual order numbers. I might expect custom orders. So I could have a custom sandwich with mayo, extra mayo, and some tomato on it. I would also expect some quality data being recorded as well. So did my toast reach the right level of brown? I should have basically an optical sensor on there checking the toast level, and the toast level is not sufficient. It should record that, and then I would constantly track what my toast level is. And if I had a long-term problem, I should fix my toaster. So this is just an example, very, very simplistic example of the kind of data that you might have in a value stream process. So the last step is creating the timeline. The timeline is defining the bottom line of your value stream map, because it will help you detect the waste in the process. And this is true whether you're looking at the whole manufacturing line or just one area in your manufacturing that we can convert into an automated work cell. Defining the timeline is very, very important. So we're going to look at the total production lead time and the individual process step lead time. We're going to look at value added time and non-value added time for each step in the process. and we're going to come up with a process cycle efficiency. And here we see this in this generic value stream at the very bottom. We can see that we've got wait times like 1 day, then we've got 90 seconds, and then we've got queue times, which might be, in this case, they've shown 3/4 of a day, 25 seconds to apply the tuna, and then half a day waiting between tuna and packaging. Sounds to me like that tuna sandwich might go bad if we did that. And then 15 seconds to package, and then 1/3 of a day to get queued up and to go out to the shipping area. I think these would be very bad tuna sandwiches by the time they hit shipping. But that bottom there, that little chart, which shows you the wait times and the processing times, and then on the right shows you your total production time, PLT, is 2.675. This is almost 3 days to get a sandwich out of the process. I do not think I would want to eat that sandwich. All right. And then it shows you my value added time is only 130 seconds. So out of that 3 days, I have barely 2 minutes, a little over 2 minutes of actual value added time. Yet it took me 3 days to get that sandwich. So my PCE is 2 minutes over 3 days, which is 0.193%. So this is a terrible, terrible percentage. It means I'm not doing well at all. So that is a classic value stream mapping tool being applied pretty generically to a manufacturing line that makes tuna fish sandwiches. So I'm going to pause our video here for Q&A. Okay, so now let's talk about how we would do this for our Workcells. Now we're using the process that's put together by the Lean Robotics textbook. The Lean Robotics textbook calls that current state value stream map. They call that the manual task map. I don't really like that term, but we're going to stick with it because we have a lovely textbook which is for free, and it does a good job of the content even if you don't like the name. So we're going to stick with the name. And the idea is this is the current state. This is the manual state. Now, it may not be entirely manual. You may have a nice automated machine or two in there, but you're going to want to increase the automation somehow by putting a robot in or doing something else. So we're going to start off calling this the manual task map. And that one's got 7 steps. And the first step is very similar to the step that we had with the lean value stream, and that is identify the cell customer. And we're also going to start talking about the supplier as well, but the main focus in the lean robotics approach for the manual task map is not the most talk about the supplier right away. It means that we have to identify the cell customer, because at the very beginning, we want to make sure that any value we place on process steps is based on the values that the customer of that cell places on the product. So we're going to very much focus on the cell customer. The second step is to define the valuable output. In other words, we're going to find exactly what we're producing and what value there is in downstream steps. And when I say value, I mean, obviously you might, if you're producing parts, you want that part to meet specifications. It's got to, have the right holes in it with the right dimensions and the right color or whatever else is a specification of the part that you're producing, assuming you're producing a part or a product. That's important as well, but there may be other aspects that are valuable that are not specifically related to a particular part. For instance, it may be important that it's in batches of 6 or 12. It may be important that it's highly clean. It doesn't have any dust on it or bits of metal shavings on it. It may be important that it's aligned properly. It may be important that it's delivered in small batches or very large batches. So we really want to understand that we understand how the output needs to look, not just from an individual part requirement standpoint, but from a value to the end customer, the next step in the process. We're also going to define the inputs. We will describe the process steps just the same as we would in a value stream map. We're going to document the flow of information, also very important, just like a value stream map. Then we're going to add one other feature, which isn't in a classic value stream map, and that is to measure the cell KPIs. KPI stands for Key Performance Indicator. Write that down if you don't already know it. These are the metrics that are going to be important for you to measure whether or not you have success. A KPI is a key performance indicator, and if you can't improve your metrics, you can't improve your KPI, then you just wasted a lot of money putting a robot in, because you absolutely have to show improvement. And the last step is to create a summary map. The big generic lean approach to value stream maps creates a lovely sheet of paper that can be hung up on the wall of your conference room or your plant. And that's great, but for a work cell, we don't need a giant sheet of paper. What we want is a nice one-page summary. So let's jump right to the summary and let's talk about this. This is your typical summary of a task map. It's the manual task map in this case. And so I guess we'll start with number one. The customer is shown as a little hexagon on the right side. The summary isn't going to include all the details about the customer, but if you have multiple customers, then you need multiple hexagons listed on the summary. You will have a separate page documenting what's important to that customer, where is that customer, and who that customer is. That'll be a separate page with all that detail. If there's multiple customers, we'll have detail on multiple customers. So you have all the detail on a separate page. But here on the summary, we're just going to see the hexagon. Actually, let's make a little circle here. And no, let's get rid of the fill on that circle. And let's make the outline red. And let's make it a little fatter so we can see it. All right, now I've got a little circle here. I can circle things. So there is your customer. Working our way back from the end, the next step is defining the output, exactly the things that are going to go to the customer. And we need to define that valuable output as relationship to what that customer needs. Now, that customer may be an end customer that we ship to, but more often than not, for a robotic work cell, that customer is just a downstream processing step. Could be packaging, it could be the next step in the manufacturing line. We don't know. It could be anybody who's downstream. We have to define the output in relationship to how they want that output. Then we're going to work our way, we'll jump back over to the input. And the input is where we get our material that goes into our automated work cell. The input could be slugs of raw steel, cut to size. The input could be in a big jumble, a big box. It could come in a rack. It could come as bar stock that needs to be cut to size. It could come in as castings. It could come in as bits and parts in bundles. It could come in, and all of those details need to be documented. Not here, right? Oops. Not in this summary, but in a separate page. We need to find exactly how that input's coming in this case, for the manual task map for the current state. All the details need to be documented. The next step would be defining the process step. All right, the process step, or steps, multiple steps added, we would have more than one box here, potentially. For the summary, though, we probably could just include all the steps listed in this one box, because showing lots of little boxes can get very crowded. So we might list all the individual steps in this one box. And then, most importantly, the value added time and the non-value added time for each step. So each step you list here, we're going to have the value added time or non-value added time. And then down here, we're going to create a summary of those times, just like the value stream map. We're going to be doing value added time and non-value added time. And the last step, or actually not quite last, the last step if it were a value stream would be the information flow. You document anything required on the information flow. This is, I think, one place where the summary doesn't give you enough information, but ideally you would list in that little circle all the different bits of information that go in and or go out of the process, and then you have to probably list that on a separate page. Now, some processes, there's really no information at all except for the production order going in, the production order telling you how many widgets you need to make at what quality level. But in many manufacturing lines, you're going to have a lot of data, and a little circle like that isn't going to be big enough to hold it. So what we do is we try to keep little bullets in that circle listing the main kinds of data, and then have a separate sheet where we list all the details. And then the last step for the manual task map, which is the lean robotics view, is we list the KPIs. What are the key performance indicators that measure how well this cell is operating? Is it just parts per day? Is it quality level? Is it anything else? Number of mistakes per day? We might have some quality measurements, like if you're making Coca-Cola, you'll test the number of defects found per bottle per day on average. So you might have a lot of different KPIs that would be used here. So let's go through an example of a typical task map summary. Let's go through the example. All right. And this is already filled in for you, so you can read ahead if you want, but we're going to pretend that the first thing you're going to do as a technician tasked with improving this process is to talk to the plant manager. All right. So here's my generic plant manager. Could be a woman, could be a man, could be anybody. Whoever they are, they've got crazy hair. All right. So you're going to talk to the plant manager, and you're going to say, all right, plant manager, somebody told me that CNC machine is causing a lot of problems because I can't find enough operators to run it. The operator who ran day shift has been telling me that you might have some requested changes around that CNC machine. So the plant manager is going to be like, yeah, I'm not going to try a crazy voice or anything, something to go with that hair. Plant manager is going to be like, yeah, I want to run 3 shifts. All right. Plus, the operator who's there keeps getting sick. He says he's got a bad back. Right. So I want to improve that part of our business. And you're going to say, how improve? Okay. And they're going to say, well, right now, my cell is only producing 210 parts per day. And you're going to go, bam, that is something important. You're giving me a KPI, which is 210 parts per day. So you've given me a metric, which is parts per day, and your current metric is 210. And then the plant manager says, and I got a problem with quality. I'm only achieving a 97% quality. And man, that is totally not Six Sigma. So, and you're going to be like, wow, great. I have another metric. Awesome. So my metric is we're going to call it first pass yield. And that's going to be at 97%. First pass yield is 97%. Excellent. You're like, wow, now I've got some really good data. And then you're going to like, all right, plant manager, is there anything else you're going to tell me you want to make this successful, that you're going to be there supporting this? And you're going to listen to that plant manager and you're going to write down everything that that plant manager says, because everything that that plant manager says at that point is extremely important. And but not necessarily important for the value stream map. It might be important because you're going to be building a sponsor. So we're going to build sponsorship. So when you go out and say, I want to spend $50,000 on a robot, that plant manager is going to be like, high five, let's do it. Now, you're done with the plant manager. And now we're going to talk to the accountant. And you're going to talk to the quality person. This is my image of a generic accountant or quality person. And I will try not to make it more insulting than that. And you're going to say, all right, let's talk about that manufacturing line. All right. Tell me what's important in that manufacturing line. And they're going to say, if it's the quality person, they're going to tell you that 97% yield is terrible. And they're going to be like, all right, 97% yield is terrible. And you're going to be like, why? Why are we not getting 99.99% or Six Sigma? Why are we getting 97% yield? And you are going to write down all the reasons. Why do we write down all those reasons? Not because these are the actual reasons that you may not get the yield you expect. You're going to write down all the reasons because you're going to be building sponsorship. And you're going to be getting hints on how you can increase the yield using an automated process. You'll be getting hints. All right. Now we can do the same thing with the accounting group. And the accounting group in most plants is usually the plant controller. You're going to reach out to the plant controller and you're going to talk about the accounting with this. And you're going to document everything that costs money in that particular process. So you're going to be documenting costs, specifically around personnel and machine. Is that CNC machine operating effectively? What's its uptime? What's its total cost? You know, what's that operator cost? How much would it cost to get more operators versus getting a robot? You're going to be developing all your costs at this point. Then, this is all stuff you do. Theoretically, you haven't even walked down to the line yet. Now, you're going to spend some time at the line. I know. Don't quit my day job. Here's your line operator. I'm not sure if he's a man or she's a woman, but there's your line operator. And look, I got my wrench here just for illustrative purposes. And I did terrible job on the feet, I know. But there's your line operator. And your line operator, you're going to reach out to him and you're going to say, all right, they're talking about problems on this line Tell me what's going on and tell me how it's working now. Now, my recommendation with this operator is you don't talk about a robot right away. I mean, if you're showing up there, they've probably already heard that you're interested in a robot. But you don't necessarily say, and I want to replace you with a robot. You don't hide it from them. You know that you don't make it a secret, but you say, all right, so tell me what's going on with this process. Why do we have 90% or 97% first pass yield? Why are we only producing 210 parts a day? The plant manager says he wants more. Tell me your pain. So the operator is usually not the person directly to be blamed for any kind of production or quality problems. Most operators they work hard. They are professional. They're there getting paid on a job. Some of them have been doing the same thing for 30 years and they're pretty darn good at it. I mean, there are exceptions, but for the most part, these are people who really know what they're doing. So you ask them to tell you their needs, their pain. And they're going to bitch about the various people that you just recently talked to, and that's fine. And you're going to listen, but you're not going to write down any of that stuff, because if you write down their complaints, then they'll think that you're going to use them against them. So instead, what you're going to do is you're going to ask them for the process steps. When they give you the process steps, they're going to probably give it to you in a way that really doesn't cover all the steps. So then you're going to want to go through it with them and video the process and time the process. I wouldn't time it in front of them. I would just run a little video camera of having them run through the entire process, the cycle, and then you're going to document open door, clean part, and the vise with air gun, pick up the finished part, place it on a tray, pick up a blank, place it in the vise, close the door, cycle the CNC machine, and the CNC machine will run, and then they'll open the door, and then they'll pick up the part and blow it off and start over the process again. All right? Then you're going to be like, all right, where do you get your parts from? So your inputs. And they're going to show you where they get their parts from. They say, oh, I got 4 types of parts. Oh, and you're like, 4 types of parts. That's really important, because that means I might need 4 different vices, or I might need 4 different programs for my robot. The parts are all aluminum blocks to start with, and they're all just stacked on a table to start with. So we're going to look at the quality of those parts. We're going to take pictures, and we're going to document anything about those parts that might make them difficult to handle based on cleanliness, size, consistency, weight, anything that there is about the inputs you're going to document there. The next step, you'll say, all right, what do you do with the parts when you're done with them? All right. So you're going to look at your outputs. And in this case, he says, all right, we put them on a tray. All right. So you go, all right, your parts go on a tray. And you're going to document what goes on that tray. You want to look at all the varieties. You want to check varieties. Because it could be that part A ends up on one kind of tray, B ends up on another, and there's a very good reason for that. And then the last step is you ask, where are you going with that part? And then you find out the operator delivers the part to the inspection station. The operator delivers that part to the inspection station. 60 parts every 2 hours. All right. But you're not done with the operator that. Once you finish collecting all this information with that operator, and you probably need a, maybe a nice cool drink of water to recover from that. Then you're going to sit down, you're going to go through the details of what he showed you and what you videotaped. And you're going to, for each step, you're going to develop the value added time, and you're going to figure out what is non-value added. What are they doing that in their process seems important to them because they're running a batch of these through the CNC machine, but what is not value added time? And you run through their video, you see that you got 75 seconds of value added time. They're physically moving the part. The part is going into the CNC, being operated on, and they're pulling it out of the part. But you're also finding you have 18 seconds of non-value added time. Time wasted may be required because you do take some time to close vices and open and close doors and all that kind of extra stuff that you have to do to run a CNC machine, but you're not adding value to the part, because the part value at time is only when you're actually machining it or moving it to have value added to it. So that is a classic post-operator interview. Now, I didn't really talk about this, but there is a subsequent step where we might go to that customer. And we will clarify the need or the value that the customer has for that part. If he's getting a rack of 60 parts every 2 hours, maybe he or she wanted that. Maybe he or she didn't want that. There might be something else that would run more efficiently for that customer. So we do have that next step is go out and talk to that customer one time to make sure you've got that covered. So there's my little not so high tech. And let's go zoom into our presentation. And we can see in our presentation now, let's make this a little bit bigger. All right. We can see we've documented everything going on in there. Here is a little process cycle. Now, this should be where we see information flow. Instead, we're seeing the flow of the operator standing in front of the information, the CNC machine, and then we've got a previous cell operator and a next cell operator. So we're showing a little diagram of exactly what's going on in that particular cell in terms of process. We know that we've got a KPI of 210 parts a day. That's our first metric. And our yield is 97%, which is our second metric, first pass yield. We know a customer needs 60 parts, and the customer is in the inspection station every 2 hours. We know that we've got the whole part family on a tray. Here are process steps. Here's some documentation about inputs. All the details and pictures should be listed on a separate sheet. And here is the summary of our value-added time and non-value-added time. And in addition to this, I'm also going to document the current state cell layout. So here we are, our current state layout. Here we've got our operator standing in front of your CNC machine. He's got parts coming in at the top, just apparently in a pile here. He puts them into the machine. He puts the finished parts out on a tray. Apparently there's an Allen key involved somewhere. I assume the Allen key is how he tightens the vise inside the CNC machine. So that Allen key is a critical tool, which is why they've highlighted it. And then here, the output is the inspection station. In this case, the inspection station is only a few feet away. He's got an air gun here he uses to blow off the finished parts before they go into that tray. So that is your classic example of a manual cell layout. So in the robotic task map, we have a very similar process. In fact, it's an identical process for the 2B. Customers, outputs, inputs, process flow, KPIs, and a summary map. We also will have an example robotic cell layout. In this case, here's our example cell layout that we came up with. And we're going to talk a little bit about how you would do layouts. That's going to be a later discussion. The layout should be optimized based on how the robot moves. Our initial layout is always going to be based on our prototype. We always want to do a prototype for the layout. Even if the prototype is just a cardboard box for your CNC machine with a hole cut to the right size of the axis of the CNC machine, or and then instead of having a robot, maybe you don't have a physical robot, you can just stand in as a robot where your movements then would match what say a 6-axis articulated arm robot would move. But you definitely need to do a little bit of prototyping. In this case, we've done a prototype where we're saying your inputs are going to be a tray coming on this side. Your robot's going to sit in the middle. It's going to load the CNC machine, and your outputs are going to be there. And that's how this particular example cell would work. Then you'd go back to your task map summary and you say, all right, based on my prototype, whether it was done with a small robot system in a lab or was based on a human replicating a robot, you are going to update your KPIs based on running that with a robot using the times, the cycle times that you can estimate with a robot doing it. You're going to put all the value added time and non-value added time with a robot doing it. You're going to make sure that you match the outputs to what the customer needs. You're going to match the inputs exactly to what the robot needs, but can be supplied by the stream upstream. Because what if that input was not in a, let's go back to our manual task map. Right now, I see a nice little set of aluminum blocks that need to be machined. If that input was not in a efficient rack to fix the position of each one of those aluminum blocks, is that going to be something my robot system can handle? And the answer is yes. If I put enough money into a vision system, I can certainly handle it. But if there's any way I can rack these parts going in, then I won't need a vision system for me to handle those parts. I can just grab the parts out of the rack. So in that case, I might want to add to my robotic task map a racked part for inputs. And here I might want to show a rack showing the parts going in. The parts are in a specific rack. So that's a classic example. Now, a rack might be one approach. You might have a manifold approach. There's a dozen different ways of setting up parts for delivery to an automated system. So we don't necessarily need a rack. The third part of layout that we haven't really talked about, input, output, process, all that's pretty important. We talked about KPIs, but the last part, the third major portion is safety. We haven't talked about safety yet. In safety, it depends on what kind of robot you've got. If you're using a particular arm robot like the Yaskawa, an industrial robot, you need to do something about this cell. What can you do about this cell? Well, you need to put a fence around the cell. Typically, a fence might look like this. Actually, let's make this fill, no fill. Let's make the fence a little thicker. Make it 3-point. Let's make it dashed like that. So here is an example of a fence line that you would put. I mean, obviously you wouldn't have it running through the CNC machine, but it would start on one side of the machine, go around the work area, and end on the other. And you would want to set up this fence so that the areas where the robot needed to reach were all within the fence. And you would probably set up some sort of access, a little turntable. Oops, I didn't mean to do that. A little turntable, for instance, here, so that I could have a racked up part on the outside, swap with the rack on the inside, easy peasy. And then the same thing for the output side. I have finished parts, have a turntable that would swing out and become available to the operator in the inspection area. So if you have the Escala, you need to put some sort of safety fence, either a physical fence, which is probably your cheapest option, or an LED light fence, such as a curtain, a light curtain option. If you're using a cobot, which is certified with sensitivity, when it bumps into something, it stops, then you probably won't need the fence, depending on how you program it and depending on your safety folk in your plant. You probably won't need the fence. So this is an example of a robotic cell layout that will match the robotic task map summary for an automated work cell.